Imagine pressing the up button in an elevator, expecting the top floor, but instead, you're zooming past clouds, planes, and a bird with a confused face. No, this isn't a sci-fi movie. It's the wild idea of a space elevator, where the penthouse view is Earth itself. Scientists have been dreaming about this cosmic yo-yo for decades, hoping to trade rocket launches for a smooth cable ride to space. But hey, building a 35,786-kilometer tether. Easy, right? All we need is unbreakable materials, perfect physics, and maybe duct tape, lots of duct tape. The space elevator, from sci-fi to potential reality. Imagine a tower so tall it pierces the sky. Reaching all the way into space sounds wild, right? Well, Russian scientist Konstantin Tsiolkovsky didn't think so back in 1895 when he looked at the Eiffel Tower and thought, what if but taller? He envisioned a structure that could eliminate the need for noisy, fuel-guzzling rockets by simply climbing into orbit. Bold idea, but physics wasn't quite on board yet. Fast forward to the 1960s, when engineer Yuri Artsutinov took Tsiolkovsky's dream and gave it a modern twist. Instead of a massive Eiffel-inspired tower, he suggested using a cable anchored to a satellite in geostationary orbit. Imagine a cosmic cloths line connecting Earth to the stars. It was way more practical than Tsiolkovsky's giant space stick. Then came Arthur C. Clarke's 1979 novel, The Fountains of Paradise, which painted a vivid picture of a fully operational space elevator. Suddenly, the idea wasn't just for nerdy engineers, it became the stuff of popular imagination. Clarke made it sound so cool you'd almost forget about the insane engineering challenges involved, like finding a material strong enough to survive cosmic tug-of-war. Today, groups like the International Space Elevator Consortium are seriously digging into this idea, researching designs, materials, and even potential uses. Carbon nanotubes, graphene, maybe some yet to be discovered alien tech. Who knows? But one thing's for sure. If the space elevator ever becomes real, it'll make your average elevator ride feel like child's play. Ground floor to geostationary orbit, anyone. Material matters. The quest for the perfect cable. Let's get one thing straight. Building a space elevator isn't just about dreaming big. It's about finding a material that won't snap like a cheap shoelace when stretched tens of thousands of kilometers into space. Traditional options like steel, too heavy. Kevlar, great for bulletproof vests, but it wouldn't survive the cosmic tug-of-war. Enter carbon nanotubes, discovered in 1991, which seemed like the superhero material we were waiting for. Ultra-strong, ultra-light, and possibly spun from the dreams of overachieving atoms. But here's the catch: making carbon nanotubes is like baking the perfect souffle at planetary scale. Sure, companies like One Chemical Substance and Alloys have made impressive strides, producing up to 90 tons per year by 2025. But weaving those nanotubes into a single, continuous tether stretching 35,786 kilometers. That's like trying to knit a scarf to the moon with spider silk. We're not quite there yet. And it's not just carbon nanotubes getting all the attention. Researchers are flirting with graphene and boron nitride nanotubes as potential alternatives. These materials are just as promising, but they're like that overachieving kid in class full of potential, but still figuring out how to live up to the hype. So, while scientists and engineers are hard at work trying to crack the code for this cosmic bungee cord, one thing is clear: the perfect space elevator cable isn't here yet. But when it arrives, it'll be a masterpiece of science, engineering, and probably a touch of magic. Until then, we'll keep dreaming and waiting for that cosmic scarf to materialize. Engineering feats beyond the cable. Building a space elevator is like assembling the most complicated IKEA set ever, except the manual is written by physicists, and one wrong move could send the whole thing crashing to Earth. First off, you need a rock-solid anchor point on Earth, preferably near the equator. Why? Because the planet's rotation provides a handy assist, Like spinning a lasso, except this lasso stretches into space. No pressure, right? Then there's the counterweight. Imagine tying a bowling ball to a string and spinning it over your head, except, in this case, the bowling ball is beyond geostationary orbit, and the string is a 35,786 kilometer tether. This setup creates the tension needed to keep the tether stable and prevent it from flopping around like a cosmic noodle. Next up, the climbers, or elevator cars. These bad boys would haul cargo and maybe even passengers up the tether. But powering them, that's where it gets spicy. Forget diesel engines or rocket fuel. The plan is to zap these climbers with wireless power. Ground-based lasers, or microwave beams, would beam energy to photovoltaic cells on the climbers, turning them into high-tech solar surfers. Of course, hitting a moving target with a laser from thousands of kilometers away isn't exactly child's play. Imagine trying to shine a flashlight on a mosquito buzzing around a football field. That's the level of precision we're talking about. But hey, if we can pull it off, we'll have the most futuristic transportation system ever. Just make sure the climbers have Wi-Fi for the trip. Economic considerations, costs, and benefits. The initial investment for constructing a space elevator is estimated to be in the tens of billions of dollars. While this figure is daunting, the long-term benefits could justify the expense. Currently, launching payloads into space via rockets costs approximately $10,000 per kilogram. A space elevator could reduce this cost to as low as $100 per kilogram, making space more accessible for scientific research, commercial ventures, and even tourism. The reduced cost could spur a new era of space exploration and development, enabling projects like large-scale space habitats and solar power satellites. However, securing funding for such a colossal infrastructure project poses significant challenges, requiring international collaboration and investment from both public and private sectors. Safety concerns, navigating the hazards. Building a space elevator isn't just about defying gravity, it's about surviving the universe's relentless attempts to ruin your day. First off, there's space debris and micrometeoroids, those tiny, high-speed bullets zipping around in orbit. One hit, and boom, your billion-dollar tether becomes cosmic confetti. Engineers are brainstorming solutions like self-healing materials or redundant cables to keep the system intact even if something goes crunch. Then there's Earth, which isn't exactly a cooperative host. Hurricanes, lightning, Mother Nature's mood swings. To dodge these, the anchor point might need to float in the middle of the ocean, where storms are less intense. Think of it as a space elevator that also moonlights as a luxury cruise liner. And don't forget the constant tug-of-war between Earth's rotation, the moon's gravity, and the sun's pull. It's like a cosmic dance, and the elevator has to stay in perfect rhythm, or risk snapping like an overstretched rubber band. Sophisticated control systems will be key to keeping this celestial tightrope act in balance. Because let's face it, nobody wants their ride to the stars derailed by a bad case of wobbly tether syndrome. Impact on space exploration. A paradigm shift. Imagine tossing out the idea of rockets entirely and hitching a ride to orbit on a glorified space escalator. A space elevator would flip the script on how we explore the cosmos. For starters, say goodbye to the weight limits of rockets. This bad boy could haul massive components for space habitats, solar power stations, or even your dream space mansion. And it doesn't stop there. The elevator could double as a launch pad for missions to Mars, the Moon, or wherever humanity's curiosity leads us. No more massive rockets guzzling fuel and cash, just a smooth, budget-friendly ride to orbit before blasting off into the great beyond. Plus, with constant, easy access to space, scientists could deploy satellites, run experiments, and even send up pizzas for astronauts without breaking the bank. In short, the space elevator wouldn't just be a game changer, it'd be a game maker, unlocking possibilities we can only dream of today. The future of space is looking up literally. And there you have it, our wild ride into the future of space elevators. If this cosmic dream blows your mind as much as it does ours, Smash that like button and hit subscribe for more mind-bending ideas. Don't forget to share this video with your friends. They deserve a ticket to the stars too.